Statistics. Today we are going to look at section 11.2 where we're going to talk about, again, two samples. That's what we're talking about in this whole chapter 11 is having two different samples. And today we're going to talk about having two different means that are coming from dependent samples, which we said in the last section could be thought of as matched pairs. So what we're going to be doing here is statistical inference on matched pairs data. What that's going to do is it's actually going to take these two samples and essentially turn them into just a single sample by taking the differences since they are perfectly matched up. So we're going to take the difference between, or the subtraction between those two sample values, which would create like only one sample set of data then, and analyze that set of data. So here's what we need to be able to do this. We need our samples, the first sample, to be done by simple random sampling. Then we need the second sample to be matched to that in some way. We need the sample to be more than 30. Again, with your project, that's why we had that as our number on that, the magic number of 30. We need that sample to have more than 30. And we need the sampled values to be independent of each other. So person number one cannot affect that second one. We can set up our hypothesis in all three ways. Here, that mu is for the mean, and then the d is for the difference. So it's saying the average difference between them is 0, or not 0, or one is bigger, or the other one is bigger. We select our level of significance. With means, we're working with a t statistic instead of that z statistic. Remember the difference between that? It's really subtle because the bigger the sample you get, that t distribution becomes very much like the normal distribution of the z. But the key difference here is that t allows us to work from our sample standard deviation, which is something we can actually calculate, as opposed to z requiring the population standard deviation, which we just don't typically have. So that's why we use our t's here. We have our degrees of freedom, which is one less than our sample size in general. And we can compare that then to our critical regions, either both sides or one side, depending on what kind of hypothesis we have. Or we can find our test statistic and find our p-value out of the chart and compare that p-value, either, again, the one-sided or two-sided, to our alpha level. We use technology to find our p-value and our test statistic, and then we decide whether or not to reject our hypothesis. These procedures are robust, which means that even if the population is not normal, it should work out okay. However, if we have outliers, that's kind of a no-go. So it doesn't need to be perfectly symmetrical, but if there's anything that's just like way off the charts, we shouldn't be using it. So it's a good idea to check for outliers. All right, so the following data represent the cost of a one-night stay in a Hampton Inn hotel and a La Quinta Inn hotel for a random sample of 10 cities. We're going to test the claim that Hampton Inn hotels are priced differently than La Quinta. Okay, so here's our data, and these are matched up according to city, because different cities might have different kind of cost of living, and then thus have different price ranges. So we wouldn't want to compare a hotel price in Grand Rapids to a hotel price in New York City, right? So they're paired up according to what city they are in. And we are wondering if they are different. That was the claim. So to do this, I went ahead and put this data into StatCrunch. Now, what this does, because they are matched pairs, what the calculation is going to do, and we're not going to do all the steps of it because it's going to happen in the background of StatCrunch when we choose things out of a menu. But what StatCrunch is really going to do is take these differences. It's going to do a subtraction and kind of create a third set of data that it's not going to give to us, but it's going to do that. So it's going to say 129 minus 105 and create that new set of data here. 149 minus 96 and create that new set of data there. And so that's what this slide does, is finds those differences for us. And then it analyzes those according to like a single sample like we did in the last chapter. So what we'd want to do first is make sure that we don't have any outliers happening here. So to do that, we could just create a quick graph. Really what we'd want to make sure is that there's no outliers in the differences though. So I would actually have to create that third chart. And I feel like there's a way that I can define this to do that subtraction, I thought. That's just wanting me to change it. What if I say it's equal to no, it's just wanting me to rename it. Let's see. Okay, I should have practiced this beforehand, I guess. I know how to do it in like Excel. I don't know how to do it in here and make it do the subtraction, but like equals this. No, see, it doesn't want to do it. That's how you do it in Excel. But that's how we would actually create the box plot, would be to actually find those differences. And I'm sure it's very easy, and help would show me how to do that here quite quickly, I'm sure. But we'll just go ahead and run our, here's the box plot on it so we can see that there are no outliers. So we're going to go into proportion stats. Oh, no, sorry, not proportions. We're not doing proportions. We just did in the last section, which for me was just moments ago as I'm recording these back to back. But we're going to go into our t-stats when we work with means. We're doing t's. We never use these z's here. Just don't ever use those. T's or proportions. So we go into our t-stats. We have two samples, but they are paired. So we're going to choose this paired here instead of choosing the two samples. So we choose paired. That's where it's going to take those differences. Sample 1 is in column 1. Sample 2 is in column 2. We are testing the claim that they are different. Now, if the claim was that one of the groups is bigger than the other group, I'd have to pay attention to which group I put into list 1 and list 2. So if I was, for example, testing the claim that Hampton is more expensive than La Quinta, then because I put Hampton into list 1 and La Quinta in list 2, if this sample is more than this sample, 1 is more than 2, I would then want a greater than 0, because bigger minus smaller would be greater than 0. But our claim in this was just that they're different. So now that I'm looking in here, we might be able to check out a box plot here. I'll go ahead and do that and just see what that looks like. All right, so we can also add in our summary statistics as well. I'll go ahead and add that just so you can see what those are. All right, so we'll compute. Okay, so on this first screen, it gives us the mean and standard deviation for each group separately. So the mean of the Hamptons is 141. The mean of the La Quintas was 89. So it seems like they're different, right? That was our question, is they're different. It does seem like they're different. Then when we look down here, this mean right here is the mean difference. How different are they? On average, it seems that they are over $50 different. That seems different, right? So then we look over to our t-stat. Remember, t's are kind of like z's. How many standard deviations out? Over 5. So remember, 68, 95, 99.7 at the third one. We're going out to the fifth one. That seems way out in the tails, and our p-value is very tiny. So really at almost any level of significance, we are going to say we do have enough evidence to say that the prices are different, to reject the null hypothesis that they are the same in favor of the alternative, that the prices are different. Here's that box plot. It does look, there's a dot out here. That looks like one is possibly an outlier. but I don't know what that would be. Row 5. Oh, that's because that's the one case that the La Quinta was higher than the other one. So that's why that one's over there. All right, so this just goes through those same things. There's the box plot. Here they calculated the t again being more than 5, comparing that to either the critical region or the p-value, which the p-value was pretty much 0 here, 0.00052. So we reject our null hypothesis and we conclude that they are priced differently. Now, that could raise the question of how different are they priced? Yeah, they're priced differently, but like enough that anybody would really care. Like a couple bucks different, not a big deal. 20 bucks different, maybe a bigger deal. Like how different are they? That's where a confidence interval can come in. So for our confidence interval, it takes that D bar is the bar means mean or average. So it's the mean or average. D stands for difference. So it takes the average difference between them and adds and subtracts some amount, that margin of error. So the interval, it says, is exact when the population is normally distributed. It's only approximately correct if it's not normally distributed, and we need large N. Large, again, is kind of relative, but we tend to think of at least 30. So we have a small sample here because we only did 10 in each group. So this is a small sample. So we would have to hope that the population is pretty normal. So if we create a 90% confidence interval on this, I'm going to come into stat again, t's, and they are paired. I got column 1 and column 2, and I'm going to choose confidence, and it says a 90% confidence. And I'm going to compute that. And it says that they are with 90% confidence, between about $33 and $69 differently priced. Between $33 and $69 differently priced. Now, because 0 is not a part of that interval, that again confirms the fact that they are differently priced. If 0 was a part of the interval, then it would be possible the difference is 0. But 0 not being a part of the interval tells us they are differently priced. How different? Between $33 and $69 different. So is that enough? We talked before about the difference between statistical significance and practical significance. Is this a practically significant difference? No. It depends on somebody's budget. It could, for sure. I mean, more than $50 different, that could definitely make a difference in which hotel somebody might choose. All right. And that was the last example here. So that is the end of our lesson on matched pairs means. So let me know what questions you have about this, and I'll see you again soon.